Dear all, good day. Today I'm going to impart my lecture number 47, which of course in continuation to my previous lecture which was imparted few days ago, that was lecture number 46, part 1. And the subject matter was the safe anchoring procedures, what all to be followed. And that is the reason the heading of this particular series of lectures, as what I'm imparting, I've named it as why the anchoring has become a critical operation. Why basically it has been construed as a critical operation. That is a point to ponder. That is what we need to think about it. And what I'm trying to do or promulgate to my fellow mariners, basically to have an introspect as far as the safe anchoring operations are concerned, in and with cognizance, with the practical knowledge of the seamanship. So now we begin. Again, I repeat, this is lecture number 47, the safe anchoring procedures. What all to be done? Part 2. The part 1, I had shown even a video from the DNV as well. And now in part 2, we are going to talk about the remaining things. And thereafter, I'll be also broadcasting part 3. And furthermore, we'll keep going on subject to my followers, my comrades' request. So, why the anchoring has become a critical operation? In the part 1, I'm just going to recap the part 1, what we had talked about under A, internal factors, and what were those? Lacking of planning and unskilled crew, master's lack of situational awareness, weather forecast in case of an inclement weather conditions are setting in. Basically because of the ignorance of lots of factors which we had talked about in my part 1 lecture, right? Lecture number 46. The second thing which in the recap what I'm talking about as per the previous lecture was is the condition of anchor, the anchor chain, deformation of anchor chain, links and studs, and the age of vessel respectively. Point number 3, condition of the joining shackles, which we need to check and which was shown to you in the previous lecture as well. Condition number 4, the condition, point number 4, the condition of windlass. How your windlass is, are we looking into the windlass if we need to change the brake liners or do the routine maintenance so that it does not turn out to be into a critical maintenance. And condition of the windlass brake liners, which I've already talked about earlier. Thereafter, point number 6, master and crew unaware of the limitation of windlass and machinery. Now this is just a recap of what I had broadcast in my lecture number 46. Now we talk about part 2 under the same heading, that is why the anchoring has become a critical operation. Part 2, the external factors. Now we will talk about the external factors. First we talked about in part 1 were the internal factors. Now it is all about the external factors. So the point number 1, it is about the knowledge of the prevailing wind, sea, swell, current, tides as applicable in cognizance with the weather conditions in which the vessel is planning to anchor. Now here, the thing what we need to understand is this is along with the due consideration of weather forecasts, because weather forecasts are broadcast synoptically, and in case, of course, when you are in the safe haven, well within the VTS coverage area, they do broadcast of any inclement weather conditions if they are setting in well in advance. Now also it also is a part and parcel or also accrues towards the limitations of the anchoring equipment. Now, many a times, without prejudice, I will say that the masters think that, okay, the vessel is now anchored, so she's safe and we all are hale and hearty, nothing will happen. Well, that's a wrong perception. Even as per the International Association of Classification Society, there are limitations with your anchoring equipment. It is designed to sustain a specified limit of external load or external strain, and that's what we are going to talk about. So, the anchoring equipment is designed for 25 meters per second wind speed. In other words, it can sustain, as per the IX, International Association of Classification Society, where they had done loads of research, basis which they have come out to this figure that it should be able to sustain maximum 25 meters per second of the wind speed, 2.5 meters of the current, and no waves. In the second part, we'll talk about the waves also is there, but in case the wind is 25 meters per second and the current speed or the rate is 2.5 meters per second, then if the waves are there, it is certainly going to increase the load upon your anchor chain and your anchor equipment as well. However, an equivalent sustainable load as per IX is 2 meters of waves, 1.5 meters of current, and 11 meters per second of wind. If we see the difference, in the previous point, it was 25 meters per second of wind. Here it is 11 meters per second of wind. The wind has been, scale has been reduced. And the current in the previous point was 2.5 meters per second of current. And here it is 1.5 meters per second of the current. And in the previous one, there were no waves. Here the waves allowance has been given 2 meters of the waves or sea or swell. So now you see the difference and the contrast. Under the given circumstances, what all are the sustainable load which your anchor chain and anchoring equipment can sustain. Therefore, we cannot undermine, we cannot ignore the external factors as far as the weather constraints or whenever the inclement weather conditions are going to set in. We go to the next slide. Point number 2. The windlass motor is designed in accordance with the minimum class requirement to lift 3 shackles of chain, that is the vertical depth of 82.5 meters in length of 3 length of chain. In other words, if the chain is vertically up to 82.5 meters of length under normal weather conditions, not under rough, under sustainable fair weather conditions, our windlass shall be able to pick up 82.5 meters of chain, which is equivalent to 3 shackles. That's what I'm trying to say. Point number 3. Now, letting go of an anchor should be only between the depth of 20 to 25 meters. Now, when I talk about this, and coming from the old schools of thought, trust me, even myself as a master, I would say 90 to 95% of times, I would prefer to walk back the anchor instead of letting go, irrespective of whatever the depths are, because I want to preserve my anchoring equipment, machinery which are linked to that, to have a better sustainability, and they go in the long way. They basically, when you try to take care of your machinery, the machinery also gives you in return a good fidelity or the productivity. Therefore, I'll say, repeat this point again, letting go of the anchor should be only between depths of 20 to 25 meters. This is the class recommendation. However, if I talk about myself as a master, I have always 90 to 95% of times walk back the anchor. I do not prefer to let go the anchor. However, a good seamanship practice is to always walk back the anchor if there is no emergency and or very strong currents in the vicinity. Of course, if we have an emergency, certainly you can and you should let go the anchor. And if practically feasible, if you're going when you're going to the anchorage and you find the currents are not very strong, there are not many vessels, or there are not vessels in your close proximity or vicinity, I would prefer to walk back the anchor instead of letting go, irrespective of whatever the conditions might be. And thereafter I will lay off the catenary in a nice and easy manner, and off we go. Okay, there are a lot of other factors subject to the nature of bottom, etc., which we'll talk about as we run down the slides. Therefore, I repeat this point again. However, a good seamanship practice is to always walk back the anchor if there is no emergency and or very strong currents in the vicinity with respect to the traffic density as well, which are there at the anchorage. Now, why I said that I would prefer to walk back the anchor, as what I've stated in the next line, as it avoids the wear and tears to the anchor chains and the anchoring equipment respectively, and you preserve your anchoring equipment accordingly. Because talking about from a layman's point of view, I mean, so anchors are your brakes besides your stern propulsion. So I would rather prefer to preserve my brakes for any kind of eventuality. Under the normal routine work for anchoring, I would rather prefer to walk back the anchor instead of letting go the anchor. Now the next point, what I stated earlier, that is point number 4, nature of seabed. Now clay is the best holding clay has the best holding power, but it has a sucking effect. Clay definitely is a very good holding ground, but it has a sucking effect because of the its softness. Therefore, if you are anchored in a sea bottom which has a clay, you must, if you are anchored for a very long time, you must pick up your anchor and re-anchor, because it, as stated in this particular line, it has a sucking effect because it sucks it. Because if there's a suction effect, then when you're picking up the anchor chain and the ship is swinging around it, the chain may get entangled or twined in such a manner that you may have a problem when you're picking up the anchor finally. Now, second point is shingle and sand also has a good holding power, but the mantra is, in case you're anchored for a very long time, a good practice is to pick up your anchor at same place and re-anchor, so that during the swinging of the vessel, your anchor chain doesn't get twisted or entangled, or in such a manner that when you're picking up the anchor, you have to untwine the anchor chain. So that also is a problem many a times. Pebbles, cobbles and soft mud, they have a low holding power. Anchor may drag, and the dragging identifying the dragging will be difficult. What I'm trying to say is that like pebbles, cobbles and soft mud, that has a low holding power or low holding grounds, and the anchor in case of dragging may drag, but it is very difficult to identify that you are dragging anchor at a very small rate. So that's where one has to be very cautious. Next point, anchoring is not recommended in the shell or rocky bottoms and or near the vicinity of contours and slopes. Now, one must not anchor into a rocky bottom. If we have to anchor, there is no other option. Do not let go the anchor. Walk back nice and easy. Once you walk back, let's say up to 3 to 4 shots, stop your walking back, give your stern kick to lay the catenary. Once the catenary is laid out, the chain is getting laid out nice and easy, which I have shown in the next slide also. The chain is laid out nice and easy, because when the vessel is at anchor, it's not the anchor, it's the catenary which is laid out. That's the one which holds the ship at the anchorage. However, saying so does not undermine the statement what I made earlier, that anchoring is not recommended in the shells and the rocky bottom, because there may be cases that your anchor shank and chain, along with the flukes, may get stuck into the rock, and in case if there is an inclement weather condition, if there's a pull on the chain, you may perhaps lose your anchor, or in case of dragging, you may lose your anchor, and that's it. That is the reason. Avoid anchoring in the vicinity of rocky bottoms and shells. Now, I've seen many a times, I've experienced, even when I was at, when I've anchored my vessel, I see many a times there are vessels which anchor as what I've seen, I've shown you with my marker. Like in this case, there is a 30 meters contour, and this vessel you see, I've shown you, is anchored very close to the contour. Same thing here, 20 meters contour, and this vessel is anchored, very close to the contour. Now, what can happen in case you're dragging the anchor, and suppose you're dragging this way in this direction? If you're dragging, what happens? You don't get time, and all of a sudden your anchor will fall into a higher depth. What will happen? There'll be a sudden jerk on your anchor cable and windlass, and you will have a fantastic or catastrophic amount of damage to your anchor. You may lose your anchor, and there may be a lot of other repercussions to that. So avoid anchoring near the contours. Try to give at least 3 times of your swing circle margin. If your swing circle for a smaller vessel is approximately 2 cables, give at least, say, approximately 3 times, I would say, a safety factor. But if I were you, I would give at least about a mile, or maybe 8 or 9 cables. So the safety factor for swing circle, which of course I will talk about in length in my next lecture in part number 3, but this is just to build up the tempo. Therefore, I reiterate and repeat myself that do not or avoid anchoring near the contours, as I've shown you in this example. Let's say this vessel is anchored too close to 30 meters contour, and this is a 50 meters contour. In between, the depth may be 40 meters, 50 meters or anything, but definitely not 30 meters. It may be more. That is the reason this contour line is drawn on your chart. Now think about it, that if you have anchored very close to the contour, and God forbid your anchor is dragging, what happens? Your anchor will fall into this void or in this valley. If I look at it from the plan view or bird eye view, your anchor will fall into this, and certainly there will be a big jerk of 10 or 20 meters. You can understand what has happened. You will lose the anchor, and you may damage your windlass or machinery, etc. That is the reason I've written here that anchoring in the vicinity of contours shall be avoided, as it may lead to a catastrophic situations in case of any anchor dragging, as shown in the diagram. Vessels anchored in the vicinity of 20 or 30 meters contours. Now the next point what we talk about is the scope. What is the scope? Many of our mariners, they don't have this fundamental clear, so for their sake I'll talk about it. Scope of anchor cable to be paid out with respect to the available depth of water at planned anchorage. Now this is what scope, how you should calculate, but remember, this is just a guideline and applicable only in the calm or fair weather conditions. I repeat that these are just the guidelines as per the industrial practices and as per the class and as per the practical knowledge of the seamanship, but they are only applicable for calm and fair weather conditions. Do take a note of this. So, scope of an anchor cable to be paid out with respect to available depth of water at planned anchorage. This guideline is applicable only in calm weather conditions. And what are those guidelines? Though there are several methods used to calculate amount of cable to be used when anchoring, these include, that is, number of shackles of cable which is to be paid out, that is 1.5, and this multiplied by the square root of the depth in meters. 1.5 into square root of the depth in meters in the place where you are going to drop the anchor. The second is length of cable in meters. It is approximately 6 times the depth of water. So a normal benchmark is approximately 6. You must vary it as per a lot of other factors, which I will talk about in my next slide. But mind you, as I am repeating myself, all these calculations are based on calm and fair weather conditions, and when you do not have very strong wind and the current. It is only applicable. If you have very strong current, you may have to pay out extra chain length to make sure that your catenary does not get disturbed. We will talk about the catenary in my next slide. Now the catenary, if it is not laid out properly, now when you lay out the catenary, many masters, what they do, okay, taking the example of the previous conditions, what I'm showing with my marker is 1.5 times under square and the square root of depth in meters, or 6 to 10 times the depth of water. But what they fail to take into account, the freeboard of the vessel, effect of sea and swell, and the height of tide. Now, ladies and gentlemen, these things come only from the practical knowledge of the seamanship. I can tell you that many things I'm talking about, you may not find them in the books. Now, when I say freeboard, why? Because you're taking the depth under your transducer. But do not forget that you have your transducer on the keel of the ship. Above that, you have your freeboard. That freeboard extra has also to be accrued in the scope, plus the height of tide. Let's say height of tide, for example, it's 2 meters. In other words, when it's a high water, it is going to raise you 2 meters above the datum. And in case you have a swell which is 2 or 3 meters, you add up onto that. So all these factors are also to be taken into account when you are calculating the scope. Number 1, freeboard. Number 2, height of tide. Number 3, the effect of swell. How much the swell raises you. Because in case you don't take it, ultimately you may find that your catenary is getting disturbed. Now this is the vessel I've taken into account, and this is where she is anchored. You see the green line or the green chain where the catenary has been laid out properly and the anchor is resting on the seabed. But what happens when the wind picks up and the wind comes from your bow, very strong wind? You find your anchor cable is very long stay. Let's say 12 o'clock, very long stay. So what is happening? You see this in the red line. The chain, same chain I've shown it with the red marker. See what is happening. Your chain is stretched. If your chain is stretched, means your catenary is disturbed. And if your catenary is disturbed, in other words, it has compromised upon your holding power. So take a note of this. This green chain or the anchor chain for the same vessel I've drawn here is when the anchor is laid out nicely and the catenary is laid out accordingly. But later on, when the wind force increases, it is going to push the vessel behind, and when it is so, your anchor chain will stretch to maybe about 12 o'clock, very long stay, or whatever the stay. But at that point in time, do not forget, that is what I've shown in this diagram. Look at this cable, the red marked cable, the way it is stretched, and this catenary is disturbed. This catenary is disturbed. So in case if I draw this line here, that is over here, this is the catenary which is marked here in this case, But if I go in here, draw this dotted line, your catenary is disturbed. It is completely disturbed and it is compensated for your anchor holding power. So make no mistake, if you find your cable is stretching and the wind force is increasing, the best possible thing is to pick up your anchor and drift or move towards a safe location. This is what I would very strongly recommend to my comrades, my master. So coming to this point, what I'd stated earlier is the importance of the catenary which holds the vessel at anchorage if laid out properly whilst anchoring the vessel. This is as shown in the green chain, what I've shown in different colors to make us understand clearly. During the inclement weather conditions, the catenary gets disturbed and leads to the compromise in the vessel's holding power, anchor chain, very long stay or a long stay, whatever it is. I will talk about the swing circle and how to ascertain with the practical knowledge of seamanship, as far as how to know with the practical knowledge of seamanship, that how would you know that your vessel is dragging anchor. That is, hypothetically speaking, that your GPS is not working, everything is failed and you are all by yourself. How would you judge with your practical knowledge of the seamanship that you are dragging the anchor? This I will broadcast in my next follow-up lectures. Hence, while calculating the scope, the factors of the freeboard, sea swell, inclement weather conditions and the height of tide shall also be taken into account, what I stated earlier. Now, as you know that I have already broadcast quite a few lectures on incidents which had taken place as per MAIB report in my previous lectures. And that's where I'm coming from when I talk about action by the master in case of presence of other anchored vessel in the close proximity in the planned anchorage, importance of correct calculation of the swing circle, that will be explained in part 3. And how to ascertain swing circle correctly in advance and what practices to be followed as far as the practical knowledge of the seamanship is concerned. All this and more will be followed up in my next upcoming lectures, as I hope you all may appreciate that I'm doing this all for our mariners, for our seafarers, especially masters and the senior officers. Again, repeating myself, what all things I am trying to, relate to you all is all based on my practical and pragmatic experience. I request you to watch this and do come back with your comments onto my YouTube channel or LinkedIn, whatever you may feel comfortable with, and ask your colleagues and comrades also to come to me if they have any doubt, and I will do the justice whatever I can. With this, I thank you all for giving me all this encouragement by liking and subscribing my channel on the YouTube under the banner of Marine Quest Solutions. I will be broadcasting my next lecture number 3 in due course after I see all of your support, comments and queries. I will try to resolve whatever best I can. I certainly will do the justice with them. Thank you very much. Good day. God bless. Stay safe.